So in this video, we're going to find a limit that involves function composition. So function composition, remember that means that you're taking two functions and you're plugging one function into the other function as an input. And so Theorem 3.3 says suppose we have two functions f and g such that the limit as x goes to a of g of x equals L. In other words, this limit exists. And if the limit as x goes to L of f of x equals f of L, then if we're finding the limit of the composed functions f composed with g, if we take the limit as x goes to a of f composed with g of x, then we just take f, the function f, and evaluate it at the limit as x goes to a of g. And because this limit is L, we replace this limit with L and we just evaluate f of L. So how this plays out in practice, let's suppose we have a limit. This is a function composition because we have an inverse cosine function. And inside of the inverse cosine function is the linear function x plus the square root of 3 over 2. So we have a linear function being input into the inverse cosine function. So I have a function composition, so I want to try to apply Theorem 3.3 to find the limit. So step 1, rewrite the function. Limit as x goes to 0 of the cosine inverse of x plus the square root of 3 all over 2. So the step one is to look at the function on the inside, the x plus the square root of 3 over 2, and ask yourself the question, does the limit as x goes to 0 of this function exist? And what we want to recognize is that this is really just the linear function 1/2 x plus the square root of 3 over 2. It's in the form mx plus b. So a linear function has the domain that goes from negative infinity to infinity. In other words, a linear function is defined for all real numbers. And 0 is an element of the open interval from negative infinity to infinity. So we can use Theorem 3.2, which was the theorem we looked at in the previous video, and say, hey, to find this limit, I just can plug 0 in. I can evaluate the function at 0. So I drop the limit notation because now I'm plugging the real number 0 in for x. 0 plus the square root of 3 over 2 equals the square root of 3 over 2. So the limit does exist. So for my function composition here, I'm going to rewrite this as I'm going to take the limit as x goes to 0 of the cosine inverse of, we're going to take the limit as x goes to 0 of the inside function, x plus the square root of 3 over 2, right? The limit as x goes to a of f of g of x is the f of the limit as x goes to a of g of x, as long as that limit exists, which it did. So now I can take the limit of the interior function, which I did right over here. I can say, hey, this is going to be the limit as x goes to 0 of the cosine inverse of the square root of 3 over 2. And then I need to identify, does the cosine inverse of the square root of 3 over 2 exist? And of course, the cosine inverse function is defined for all x on the interval from -1 to 1. And the square root of 3 over 2 does live on this interval. It's a number that's smaller than 1. For example, if we had, erase, please. If we had 1/2, which is less than 3/2, which is less than 4/2, and then we took the square root of each of those numerators, we would get that this number here, the square root of 3 over 2, is between the square root of 1 is just 1, is actually a number between 1/2 and the square root of 4 is 2. 2 divided by 2 is 1. The square root of 3 over 2 lives between 1/2 and 1, which is clearly on the interval from -1 to 1. So because the cosine inverse is continuous on the interval from -1 to 1, and the square root of 3 over 2 lives in that interval, we can just plug the square root of 3 over 2 in there. And then we want to recognize that the square root of 3 over 2 is corresponds to a special angle. So if we have on the unit circle, we have a 30-degree angle. So 30 degrees, or we're talking about pi over 6 radians. Then on the unit circle, you have the ordered pair root 3 over 2 comma 1/2, and the cosine inverse is going to be the x-coordinate on the unit circle. So the cosine inverse of the square root of 3 over 2 is going to be the angle in radians that produces the ratio root 3 over 2 on the unit circle. So we're just going to get pi over 6 radians as our limit.